For a particular, this is notes, sample, one sample proportions, and this is scenario 2, and this is page 183 of the notes. So this is page 183 of the notes, and this will be for a hypothesis test. So for a particular shopping mall, 60% of the visitors spend over $25 when they visit the mall. The mall was recently remodeled, and the shops are trying to determine if the percent of visitors spending at least $25 has changed. Notice it says has changed. At this point, we don't know if this is going to be a less than or greater than. So if it says has changed, we're thinking right now that it might be a not equal. Now, we don't know until we read further. We have a simple random sample of 550 people leaving the mall. Showed 64% had spent over $25. Provide statistical evidence to answer the vendor's question using a hypothesis test. Well, they had, this was the initial claim, and since we don't have a direction, our null hypothesis is that it's 60% because that's what it was originally or has been in the past. So PO is not equal to 60%, and the percentage of people shopping at the mall spending over $25 is not equal to 60%. Didn't have a direction to it. And I guess the reason they didn't have a direction is like it could have gone up or down depending on whether people liked or disliked what was changed. So P naught is the true population proportion of mall shoppers who spend at least $25. Conditions. First conditions was a random sample. It was given that we have a simple random sample. In the sample size needs to be less than 10% of the population. So 550 divided by 1 is 5,500, I believe. I believe that's a typo. Let's check that out. 550 divided by 0.1, 5,500. Let's draw a line through that and get that right. 5,500. Reasonable to assume that there are at least 5,500 shoppers in the mall. What actually we need to check for normality, NP and NQ. So 550 times 0.64 is 352. This is nice in that it ended up being a whole number, but if it had not been a whole number, we have to round. So that's greater than 10, so that's enough. And then we have 550 times 0.36, and that we got that 0.36 by going 1 minus 0.64, because that's Q. Q always, Q hat equals 1 minus P hat. And we should show that we know where that came from. So, and then remember P hat equals X over N. We have X is 550, and so we have 352 successes. All right, so next thing we need to do is write down our formula, which is P hat minus P naught over P naught Q naught divided by N. And here, when I plugged in, I probably should have plugged in like this. I should probably have been writing the probability. Well, first off, we know 6.4 is greater. So we should probably be writing 2 times the probability. Wow, that's not very attractive. Try this again. 2 times the probability that Z is greater than 0.64 minus 0.60 over, I'll be real careful here. Because we're using a hypothesis test, this needs to be P or P naught. It cannot be P hat. Do not use P hat here. You would if it were a confidence interval. You do not do the same thing when it's a hypothesis test. And our sample size was 550. Okay, so 2 times that. So at that point, I can go ahead and start running my test. And it's going to be stat test. Oops. And I'm going to scroll down until I get to 1 proportion Z test, which is number 5. And my P naught was 0.60. My X, we calculated it at 550 times 0.64. And when I do that, I get a whole number, so that's good. If I didn't, I'd have to round. Then this is 550. And we're supposed to be using a not equal. So we end up with 2 times the probability that Z is greater than 1.9148 equals 0.0555. All right, so we end up with a p-value of 0.00555, which is greater than 0.05, not by a lot, but by a little. 555 is definitely greater than 500. So we failed to reject a null. So our p-value is 0.0555. We failed to reject the null. There is not sufficient evidence that alpha equal 0.05 to suggest that the true population proportion of shoppers who spend more than $25 has changed from the 60% prior to the remodel. We cannot say that the remodel changed the percentage of shoppers who spend at least $25. That's what we basically end up with. So the next thing says, explain the meaning of the p-value in context and the type of error that may have been committed. Well, there's a 5.5% chance that we would get a test statistic, this extreme favoring the percentage of mall shoppers had changed when in fact the null is true and the percentage of shoppers had not changed. In other words, there's a 5.5% chance we get a test statistic this extreme when in fact the null is true and the percentage had not changed and it's still 60%. Since we failed to reject the null, the only type of error that we commit is a type 2, remember? Fail to reject type 2. Fail to type 2. Don't forget that. So a type 2 is failing to reject a false null. In this context, we believe that the percentage of shoppers spending $25 had not changed when it had. As a consequence, the mall owners will not be able to charge the shops higher rent if it had gone up, or we cannot say that it made a difference. You know, the remodel made no difference in the amount of money that people were spending. All right, we're going to go ahead and on the same video, we're going to do the confidence interval. And it says the simple random sample of 550 people leaving the mall showed that 64% had spent over $25. Calculate a 99% confidence level and provide a conclusion. I just brought this over from the original page because originally they were spending 60%, and now I want to know 99% how much is being spent. Here's my restatement of the parameter. The true population proportion of mall shoppers who spend at least $25. And this is really after the remodel. It's those shoppers. And I'm just saying that for your clarification. This is a good enough sentence for what we're doing. Conditions, they told us previously random sample, and we can go back and look on page 183. Where we previously did all this work. So page 183 for conditions. For conditions. That'll speed this up a little bit. All right. So we have everything except we need to write down our formula. And our formula in this case is p hat plus or minus z star p hat q hat n. And I'm going to, as usual, I'm going to take just a moment and please note the difference here, because when we run a confidence interval, this is what our standard error is, and when we run a hypothesis test, so here we're using the p, here we're using p hat. Please remember that confidence intervals get p hat, hypothesis test uses the true population proportion. All right, so sample proportion true population proportion. Got to make sure that you have that correct in your formula. Otherwise, you'll lose a lot of points, about 25% of your scores. Be careful of that. All right, so this is our formula. We know P hat because P hat is going to be the 0.64. So what we need to calculate is Z star. Well, they wanted us to calculate a 99% confidence interval. So second vars, inverse norm, area, parenthesis 1 minus 0.99, close parenthesis, divided by 2. Mean is 0. Why? Because we're working with a Z, standard deviation of 1. And we're just going to go calculate this thing. And we end up getting 2.575. All right, so what was our P hat? And I'm not sure how I ended up getting the numbers that I have. I'm going to pause this for just a moment. That's always nice to find out that the numbers that you use the wrong numbers. So basically, everything I've said has been correct, but what's written down in the notes is incorrect. We're going to need to ignore this part because our P hat equals 0.64. So when I plug into this equation, I should have had written, this is what should have been written, 0.64 plus or minus 2.576, 0.64 times 0.36, because that's just the P hat equals 1 minus Q hat. So basically, that gives me the 0.36, and my sample size was 550. All right, so let's go ahead and run the test. This is going to be a stat test, 1 proportion Z interval. So we're scrolling all the way down to letter A. X, we can go 0.64 times 550. This must be rounded to a whole number. Fortunately, it already is. And also must be a whole number. Our confidence level needs to be 99%, so 0.99. And we end up getting the interval 0.587 and 0.693. So we are 99% confident that the true population proportion of mall shoppers spending more than $25 lies within this interval. All right, so somewhere between about 59% and 69%. Because 60% lies within the interval, we do not have sufficient evidence to say that the remodel changed the percentage of shoppers spending more than $25. And in repeated sampling, we expect this method will capture the true population proportion of mall shoppers spending more than 25%, 95% of the time. And really, that is incorrect. It should be 99% of the time. Why? Because we ran a 99% confidence interval, right? So this needed to be changed to 99%. Sorry for the errors. I hope that helped rather than confused. And we will do scenario 3 in the next video.